Welcome to clickmyproject.com. Now we are going to see the paper Automatic Discovery of Personal Name Alias from the Web. It comes under the domain Data Mining. Identifying entities in web documents is necessary for various tasks such as relation extraction, social network extraction from the web search, and integration of data and entity disambiguation. Identification of entities on the web is difficult for two-dimensional reasons. Different entities can share the same name, called lexical ambiguity. Secondly, a single entity can be designated by multiple names, called referential ambiguity. Referential ambiguity occurs because people use different names to refer to the same entity on the web. Many modern search engines provide a brief text snippet for each search result by selecting the text that appears in the web page in the proximity of the query. Such snippets provide valuable information related to the local context of the query. For names and aliases, snippets convey useful semantic clues that can be used to extract lexical patterns that are frequently used to express aliases of a name. An individual is typically referred by numerous name alias on the web. Accurate identification of aliases of a given person name is useful in various web-related tasks such as information retrieval, sentiment analysis, personal name disambiguation, and relation extraction. In this paper, we propose a method to extract alias of a given personal name from the web. Given a personal name, the proposed method first extracts a set of candidate aliases. Then we rank the extracted candidates according to the likelihood of a candidate being a correct alias of the given name. We propose a novel automatically extracted lexical pattern based approach to efficiently extract a large set of candidate alias from the snippets retrieved from a web search engine. We define numerous ranking scores to evaluate candidate alias using two approaches: bad co-occurrences model and page count on the web. To construct a robust alias detection system, we integrate the different ranking scores into a single ranking function and display a best alias name of a given personal name. Next, we see the flow of our process. First, we load the training data. The training data contains both personal and alias name pairs. We get all training data and store into database. Then, we enter the input personal name. We extract the snippets from our input dataset. We extract the snippets related to our input personal name. Then, using the pattern extraction algorithm, we extract the patterns between personal and alias name pairs. Then, using candidate alias extraction algorithm. In this algorithm is used to extract the candidate alias of a given personal name. Then, final process is candidate ranking algorithm. Considering the noise in web snippets, candidates extracted by the lexical patterns might include some valid invalid aliases. From among these candidates, we must identify those which are most likely to be correct alias of a given name. Considering the noise in web snippets, candidates extracted by the lexical patterns might include some invalid aliases. From among these candidates, we must identify those which are most likely to be correct aliases of a given name. We model this problem of alias recognition as one of the ranking candidates with respect to a given name such that the candidates who are the most likely to be correct alias are assigned to the higher rank. First, we define various ranking scores to measure the association between the name and the candidate alias using three different approaches: lexical pattern, word co-occurrence model, and page count on the web. Combine these three ranking methods and produce combined ranking score. We rank the set of candidate alias in the descending order and display the highest ranking alias as the best alias of a given personal name. Next, we see the running procedure of our process. First, open the NetBeans. Then open our project into NetBeans. Then add all jar files into libraries. Right click that extract pattern.java and click run file. First enter the personal name for search. For example, we enter Michael Jackson. Then click the search button. Click snippet button. The snippets are extracted from the dataset. These are the snippets related to our input query. Then click extract candidate button. Click stop word removal. We remove all stop words from the snippets. Then click pattern. The snippet contains 4 patterns. Then click extract candidate. Click candidate alias. The personal name Michael Jackson contains 6 alias names. Next one is ranking category. Totally we have 3 ranking categories. First one is lexical pattern and co-occurrence. Finally page count model. Click lexical pattern. First we calculate the frequency of each alias names. Then calculate the DF. This is the final answer for each alias names. The next click the ranking category. The next process is co-occurrence model. First calculate CF, then TF IDF and final frequency. This is the final rank for each alias names. Click ranking category. Final model is page count model. First calculate the web dice, then web PMI. Final process is sum of dice. Okay, this is the final answer for these categories. The next process is combine all models. We combine all 3 models, 3 ranking methods into single method. Click combine rank button. Okay, this is the final rank. Then click order of ranking. So Peter Pan contains 7.0. This is the first answer. So click the best alias name. So Peter Pan is a best alias. Click graph 1. This graph represents the final score of each alias names. Then click graph 2. This graph represents each alias name contain the final score for each 3 categories. Thanks for listening.